Okay, can you hear me in YouTube? Okay, the Zoom meeting is live, so you can join the Zoom meeting. Okay, can you hear me in the Zoom? Are you okay? How are you? Jesse, William, Ben, Ali, Mahana, Accounting, Monica, Rana. Okay, can you also log into YouTube Live? Okay, all right. Okay, I think we're missing. Let me see. Well, we're missing. Okay, I think everyone is here. Is Monica here? Monica? All right. Okay, so let's get started. So the first thing I want to go over is any question about project one and two. project one. Okay, no problem. Let's go over that. Okay. If you recall the assignment D5, so what you did was you read in a big image file from the SD card, and then you process them, and then you dumped the output into a file. It's a text file with all numbers. Okay, and to prove that your program works is that you use the VGA emulator number 3 to open up the file that you created using your program. And then the VGA is going to process the numbers as they were image values and then show you the end output. Okay? But that was one time deal. You cannot do another one and close the VGA emulator and then start over again to process a new file you created. Okay? So everything was static. One time deal, that's it. So for the projects, it's dynamic, meaning that you collect your board, you COM3, the serial port number 3, and then you just keep outputting files, sorry, not files, keep outputting values through the serial port, and then the emulator is able to process the incoming data and then interpret it as uh, pixel values. So you look at the screen. This is a file that I give you as a template. It shows you what you can do with the emulator. The first thing we'll do is we create a buffer, which is a byte buffer that's exactly the size of the VGA. So it's 240 rows by 320 columns. Then we'll open up the serial terminal, which is 115,200. That's the speed we're using. Okay. Then we check if the USB terminal has been opened by the emulator. If the emulator does not open your serial, it's going to stay in the loop forever. Okay. If the USB connector, which is the serial, has been opened, and then you're going to initialize your buffer to all black, because that's what you start with, all black. Okay. And then what you're going to do is you're going to read from your files and then dump the values to this black buffer. So for example, here I'm hard coding a pattern just to show you what's going on. So I'm going to write an H to the buffer. So you can see that I pick a location in the buffer and then outputting the value. So 1C means green. Okay, so this is the vertical bar or vertical stroke. This is another vertical stroke of the H. And this is the horizontal stroke of the H. Okay, so once I finish that, I'm going to output it to the VGA emulator. So I give it this loop. So this loop is going to go through every single pixel in the buffer. Okay, and it's going to output one row at a time, and then all the rows in sequential. So for you, you don't really need to know the emulator and the program interaction. What you need to know is as long as you do this loop, it's going to output whatever the buffer you have to the screen, which is the VGA emulator. Okay. So the VGA emulator doesn't really care what you are sending. What it cares is if you send the entire screen, and then it's going to show it to you on the screen. Okay. So if you remember from D5, the first 7 letters you're going to read in are the A, B, C, D, E, F, G's. So you read in those, you process the data, and then you put it into the buffer that you want to output. Okay? So this is where's the buffer? This is the buffer. And then you send out everything. And then the screen will show you A, B, C, D, F, G on the screen. Then you do the same thing for H to N. Then you send again. You do the same thing for O to T. Then you send it again. So you keep doing this until you finish everything. That will give you the dynamic behavior of the VGA and then your program. Okay? So you're not doing anything different compared to 5, but in this case, you're going to do everything at once. And then you do not need to output to a file. There's no file to save. You only need to output it to the buffer. So you just copy the files into the buffer at the right location, and then you just send the buffers out. Then you're all set. Okay. So if you run this program in your setup to make sure that you can show the H in green, then you show the H in blue, then show the H in green, and keep doing this. That means your setup is working, your VGA emulator is working. So the rest is what do you need to put into the buffer. That's your job. Understand? Okay. You don't need to put the file in the buffer. What you need to do is you put in the values into the buffer. There's no more file to output to. There's no need to do that anymore. The VGA emulator 5 models the behavior of a dynamic VGA, where you send the data in as a string, then it's going to show you the values. It's going to show the string. So if you send A, B, C, D, E, F, G, it's going to show you A, B, C, D, E, F, G. Then you send in A, B, C, D, F, G with H, I, J, K, L, M, N. Then it will show you both rows. If you look at the video recording on YouTube, you can see that it is sending one row at a time, and then there's some pause in between. So we put in some delay in between to see that it's showing the one row, and then you show it in a row, and then a row. So what the program is doing is it's just outputting letters and digits in sequence. So every time it outputs, it's going to be one screen. One screen is 70,800 bytes. That's what this loop is for. So you can use this loop as is. It works. Okay. So if every time you want to output, you use this loop. Every time you want to update the buffer, you use something like this. You specify the coordinates in the buffer and then what value you want to use, the colors. Can you read from a file and then put the A to the screen? Okay, can you do that? If you can, that means you make good progress. Can you put B right next to A and then output the screen? Yes, you make another good progress. Okay. So once you can do A, you can do B, you can do C, you can just do one at a time. You know. So it is the same buffer we're talking about. You're using this as a buffer to hold the image you want to show. Whatever you put in there is going to show it. And then the emulator shows you how many bytes you have sent. If you sent 76,800, it's going to process it immediately. If you don't send that amount, it's going to wait for that amount to show up. Okay. Yeah. So this is the command loop to send the entire screen. This is the command to put a break or pause in between. Okay. So I recommend you to run this example first. Then try to do one letter on your own, just the A. So you read from the file on the SD card, you process it, you put the values into this buffer, and then send it. And then immediately the VGA immediately will show you the expected value or the expected image. If it's not correct, that means you are not copying so you're not putting in the right value into the buffer. That's what it means. Yeah. All right. Any? Oh yeah, no problem. Anybody else? Question? All right. So next, I'd like to talk about the D7 because D7 is due very soon. And I wanted to make sure that you guys are making good progress, making a PCB from the scheme that I gave you. But this is something that I want to go over today. Okay. For this, you can go through the self-paced tutorial textbook. This I need to show you. So last time I talked about GitHub. This is a place where you can publish your work. When I say publish, I don't mean sending emails or using cloud storage. Or when you are using cloud storage, but it is organized by you. So I'm going to show you one example of a existing GitHub. Okay, and this is the Arduino GitHub. So if you go to this address, you can see this is a GitHub account by the Arduino company or organization. Okay, so what they do here is they publish all their work in the GitHub. Okay, so on the top right corner, there's a sign in, there's a sign up. The account for GitHub is free for personal use. For commercial use, you can pay a subscription, but you don't need to do that. Okay, for free account is already very powerful. Okay, all right. So this means you log into the GitHub. If you want to upload files, you have to log in. If you want to download files, you don't need to log in. So for example, right now you can see it on this screen. This is the typical look of the GitHub. You can download or you can upload. Now since I'm not logged in, you cannot upload. But if you have your own GitHub account, you can upload because every time you go in there, you log into your account, then you can upload. Okay, so what's the special about GitHub? The specialty about GitHub is that first, it is organized just like a computer. You get folders like library, hardware, build, then you get files. Okay, and also in here you can put on your personal info, for example, your website, what's going on here, what it is for, and then a license attached to it. Okay, so for example, right now you click on the license, it tells you what kind of license is included. Now, since all you have finished the research paper, you should know what license you want to do, you want to use. Okay. So when you publish your work, you also publish your license, meaning okay, can you let anybody else to use this work? Yes, of course. Please do that. Okay. And you go to your account, you can create folders. For example, say, oh, I'm going to create a folder called library. And then in the library, you can put down files. Then you can put down folders inside library. Okay. And then every time you create a folder, like for example, the hardware, you can see that the path changed to Arduino hardware. That means it is under your account. There is a hardware folder and people can see it. And then you can put down files, you can put down readmes, you can put down license, you can put down whatever you want to put down. Okay? So this is a place you want to store files. And also it gives you the date. So if you look at this, this means this particular folder was updated 3 months ago. Okay, and this was updated 5 years ago. Well, wow, what's the big deal here? Well, the big deal here is you can look at the history of the files you upload. So, for example, look at the master, means that's the most current one. If you look at 1.9x beta, and then you show you different folders and different files. So if you have a lot of revisions you need to upload, automatically it keeps track of all these revisions for you. Okay? So you say, well, I'm going to create revision 1.9. Then you upload everything under 1.9. Then here is going to show you everything associated with revision to 1.9. Okay? So you don't need to upload 10 files, one for each revision. You create revision and then upload the files, and automatically it controls that revision. Okay? So let's go back to master, which is the current one. Besides the time and the date, it also shows you how many days ago you upload the files. So for example, here it says last commit, it was 28 days ago. If you want to make people to also be able to upload to your own account, you can create the permissions for them to upload, and your contributors will go up to 1 or 2 to 3. Now, if you don't want to do that, that's okay. You're not supposed to do that because this is your personal one. Unless you want to give permission to somebody else to temper your work, you do it. Otherwise, don't do it. Okay? So here it means there are 244 people uploaded work into this GitHub account. Okay? There were 7,224 commits, meaning that when people finish their work, they upload, they want to finalize it, meaning that, okay, this is final, check it in, and then they'll lock the revisions. Okay, so for a open source or public domain work, this is the typical setup people use GitHub. GitHub right now is part of Microsoft, so Microsoft owns all the GitHub platform, whether it's a hardware or it's an account or it's a software or it's an intellectual property, they own it. But they give you the free account access, so everybody can sign up and then work on it. Okay, so your job for assignment number 7 was to upload, publish your design on GitHub. Okay, and then you give me the link. Otherwise, I cannot find it for you. So, for example, this is the link for the Arduino. Okay, Arduino here. And if you don't give me the link, I cannot find it. So when you finish your work, you just send the link to me. Okay. So the link that you're going to have is going to be github.com slash some username slash some folder name. Then when you give it to me, then I can see you publish, you can see the license, and then I can download the files. Then I can check it. Okay. But there's a catch. You you also need to send the PDF version of your work. The reason is this. Suppose you send a file to GitHub, okay? You get credit for your file that you created, okay? All right? You get a PDF version. If this is not viewable, or for some reason you corrupt this file, I can still see the PDF, okay? All right? So every time you submit work, especially in engineering, you always create a PDF file for all your work. Okay? So you need to submit the PCB Eagle format. Sorry, the schematic in Eagle format, the PDF in Eagle format, and then the PCB layout file. So I can open your work and then look at it. Okay. So there's no need to submit tons of work. It's only 1, 2, 3 files and publish them on GitHub. So GitHub meaning here. Okay. And give me the link and then I can check your work. Understand? Yeah. So the only thing you need to email me is the link to the GitHub account. Okay, that's it. Upload the work, upload to GitHub account, give me the link, then I can go check it. D7, D7, and then you do it in the GitHub. 3 things. And then you need to specify license, just like this. So you see they have a license.txt. Click on it. This is copyright software, and this is software. This license will give you legal permission to copy, distribute, and modify. That means you can do whatever. Okay. So because you have finished your D6, the research paper, and you know what the open source license means. You cannot use it. That means it's not open source. Okay, you don't want to do that. You want to make an open source version of this of your work. Okay? Open source license without any restrictions. All right. So any question on the GitHub? I mean, once you open an account, you can upload files. You can delete files. It's up to you. It's like a cloud, but it's not strictly a cloud because if you look at a cloud, the way they would manage the cloud is that you upload your files to cloud, and then if you want to share, you give a link to a file or to a folder to somebody so they can have access. However, if you have updates, they won't know it unless they check it every day. But for GitHub, it's obvious that every time there's an update, okay, you are going to get a timestamp on the GitHub saying that, hey, this one was updated 3 months ago. This one was 5 years ago. This is 5 months ago, 3 months ago. So if you go in there, if you check it out, you can see that when it was last updated. So you keep track of the time for you. So people who are going in there, they know that, oh, I want to get the most current one. So nearly all companies, they have their own GitHub account. So for example, this is the building one. So here it lists the firmware, the boards that they can support, and then the bootloader they use. So basically, whatever you can download from Arduino.com, it's already there. It's already here, but it's organized in a different way. It's more for engineers. It's not for anybody. It's not for every people. Okay? Now, so if you look at this was updated 8 days ago. And then you click on it, you can see that some were updated 3 months ago, some were updated 8 days ago. That means somebody updated source code when they're doing a platform. And you can see that where they made changes. Okay? So you can see everything is timestamped. This is good because this is the way to check your work so that you have a revision control. If you just do it on your own, it's impossible to check because you're working on projects, and then the project may have 100 source files. So that means that you need to keep track of 100 source files revisions. How can you do that? You can't. Okay. The GitHub, it's a uh, Windows, Mac, and Linux tool. So it doesn't matter what you use; they all have the interface. Okay. But for us, we're making it easy. You create an account, you upload your work, just go through this process. All right. So no more questions. Let's go over the midterm. Okay. Yes. Anybody question? No. Yes. No questions? Okay. Let's go over the midterm. Question number one was about middle ending. So Q1. The number that's stored in the variable it's 1 million. Okay, so 1 million. And then we want to look at if you store this value in a little endian system, how does it look? Okay, the first thing you should do is you cannot store 1 million as is. Okay, just let you know. Okay, the meeting will end very soon. If it ends, I'm going to post a new link. So when we join a different Zoom section. Okay, thank you. This is what happens when you use a freeware. There's a time limit. So the 1 million is in decimal. And the first thing to do is many of you did the right thing is to convert it into hexadecimal first because you save everything in hexadecimal. Okay? So if you use your calculator, this is what you got. Okay, so you look at this equal to hexadecimal F4240. But remember, 1 million it was an integer. For integer, it's always 32 bits. So the number is 00F4242. Okay, 32-bit integer. So on a normal computer, a regular computer that's not little endian, this is how they store this. So this is not little endian. You store 0, 0 first, then you store 0f, 40, and then 42, and then 40. That makes sense, right? You store the MSB first, then you store the second MSB, and then at the end you store the LSB. However, for little endian, they do the opposite. They store 40 first, because that's the least significant, then the 42, then the 0f, and then the 00. Okay? So little endian store things differently. All right, any questions? Any questions? Yes, no? Okay. Second question. It's about SD card limitations. So when we're using the SD card on the TNC 3.5 platform, what kind of limitations you have? Okay. And then please list two of them. Now there are many, I shouldn't say many, there are more than two limitations. So what I'm looking for is only two of them. You don't have to give me everything, just two. Anybody? Anybody with limitation? Anybody with limitations? Limitations? Let's start with the first one. The first one is must be FAT32 format. Okay. So if you check your computer, you plug in the SD cards, it tells you what kind of format it is. It is FAT32. Okay. And the maximum size is 32 gigabytes. I don't believe there's a lower limit, because if you were to buy say for example 2 gigabytes, I don't think you can get it anymore. But there's definitely a 32 gigabyte limit. 32 gigabytes. Continue. You can operate one file at a time. Unlike in Windows, you can have multiple files open. But here, I'm sorry, you can only open one file for read. Alright. If you want to do another file, you close that file and then open the other one. Okay. Next, when you operate a file on SD card, you do it byte by byte. So if you want to read, you will read one byte. If you want to write, you will one byte. Okay. You can do 100 bytes, but you still do it one by one, because you read in one byte at a time and put in the buffer. And the buffer is organized as bytes. The operations are byte by byte operations of read and write. So here I give you 4 limitations. If you have any two of them, you get a credit. Okay? Any two. Any questions? Okay, that's good. So number 3 requires some calculations. Alright. So number 3, I give you a bunch of numbers that represents the beginning of the BMP file. Okay? Beginning of the BMP file. So your job to look at these numbers and figure out the size of the BMP file. know the horizontal, you need to know the vertical. Now we know the BMP files, the data are saved in little endian configuration. So the first thing to do is, hey, what is the horizontal size in little endian configuration? So you look at notes, you see that this is the horizontal size in little endian configuration. So if you look at the little endian, it's 4 bytes, A00000. But you cannot use the number as is because you need to convert it into not little endian to do the calculations. So from the routine, we know that little endian means this is the least significant. This is the most significant. So you have 0, 0, 0, and then A0. Okay? Now what is this equal to? This is equal to hexadecimal 00000080. Convert into decimal 160 or 160 pixels. So horizontally is 160. Alright. Let's look at a vertical. So from your notes, you know that the vertical is also saved in little endian configuration, but the values are 7, 8, 0, 0, 0, 0. Okay? So do some math. We construct the value. It's 78 LSB. So the number I'm looking at is 00000078. Do the math, 120 pixels. So that means your vertical resolution is 120, horizontal is 160. Okay? So if you demonstrate your calculations, you get a full credit. Okay? And there's no program in this assignment for this question. You don't need to write any program. You just need to look at these numbers. Then figure out this is horizontal, this is vertical. That's it. And then you can reconstruct the values. Any question on number 3? Okay. So let's look at the last one. The last one, you need to write a program. The last one, you need to write a program such that you can read the first. Okay. I think the Zoom just ended. Let's wait for a new link on Week09. Okay, now you can join the new link. Uh, okay, I can see the 6 people entered your channel. Zoom, and anybody else? No, can you hear me? Okay, all right, that's great. Let's continue. All right. So for question 4, you need to write a program. So the program is very straightforward. You need to write a program to read the first uh, 64 bytes of a BMP file, and then output the values in hex. Make sure it's 2 digits per byte. 2 digits, not one. 2 digits. All right. So how do we do that? Well, you open up your note or your previous program. The first thing to do is you need to include the right library. Many of you did. You need to have these libraries. Okay? And then you need to define a big buffer. The buffer has to be big enough to hold more than 64 bytes. So we know that by default we use 1,000. And then you need to enable the terminal. Otherwise, you cannot use any print. Okay? And then the default speed we're using is 9600. And then you go into your operations. So the operations are the first, you need to detect if have the card plugged in. Okay, so all we did was, okay, do you have the SD card plugged in? Yes, you do. You move on. No, put a wild one so that your program will not move forward. And then remember, after each operation, you need to put a delay there. Okay, so check the presence of the SD card. Next task is to check if the file exists. Okay, so if there's a file on the SD card, that's great. You move on. Otherwise, you stop your program by using a wild one. Then you open up the file for read. So this is a typical statement. You open up the file and then file read. Then you check if the file can be opened. If it is, then you're good. If it's not, stop your program. So you can see that after each operation, we have a delay, delay, and a delay. Alright. So now you need to read, and then you can print the values. So to read it is very easy. We use the buffer to read. So you put the bytes you read from the SD card into this big buffer. How many bytes you want? 64. That's it. So this is more than 64. Then you can read 64. So read it and then look at the values. If it is -1, that means something wrong with the file. You were not able to read it. Otherwise, you finish reading, you put a delay. So at this moment, you have all the values in your big buffer. Then you use a loop. Well, you don't want to use a loop, that's okay. But most of you use a loop. So what I'm going to do is I'm going to use a for loop, okay, to print out the values. Print out the values. And if you look at this, you print one value at a time, one value per line, and then hexadecimal. But that's the problem with this statement. This will print by default one digit per byte. So if the value is 0, you print out 0. If the value is FF, you print out FF. The value is, say for example, 1A, you print out 1A. But if it's less than a certain value, you print out only one digit. So what we need to do is we need to do extra work to make sure that we can only print everything in 2 digits. To do that, very easy. If the value is less than F, you print a 0 in front of it so that you put in a 0 manually into the print. Okay, otherwise, default is always 1 digit. Okay, when you finish that, you can close your file and then you can terminate your program. But when you terminate a program, we always put a while one such that you will just stuck there forever. Okay. So this is the solution for question number 4. Many of you got it right, but you missed the 2 digits for the print, okay, which is minor. So again, the process or the steps are: first, check if the SD card is there, then check if the file is there, check if you can open the file, then read to check if the read was successful. If it's not, don't do anything. There's nothing you can do. Okay. All right. Any question about Q4? All right. So for the final, it's going to be similar setup. We'll give you questions on you learn, then you answer them. You submit your files. Okay. So you submit your solution in a text file. Um, so now we have only one assignment due, which is the project one. Once you finish that, the only thing left is I'm sorry, let me put it this way. D7 is also due, but it was given to you a long time ago. Okay, and the final exam is on the final exam day. So I'll send some reminders for that. Okay. Project one is due next Thursday, but D7 is due this Thursday. Yeah. So we don't have multiple things due on one day. It's always staggered. Okay. So let me reminder here. Put a reminder at the beginning here. Reminder. The final is 10% of final grade, so you can expect between 5 to 8 questions. Very simple questions like this. Okay, do one little thing. That's it. Everything is due before class starts. Okay, any questions? Okay, that's great. So this is everything I want to cover today. So if you haven't started on D7, please start it now. Okay, you need the time. Okay, publishing it takes a few clicks. There's no problem. But going through the process to create the schematic ego, to create the PCB ego takes some time. Okay, it's not difficult. It's very mechanical. It's just like learning SolidWorks. And at first, it was difficult, but when you know, okay, if you do this, and everything becomes very mechanical. It's the same deal. You remember, you're not designing circuits. You're not. The circuit was given to you. Okay. If you don't have any questions, you can log off. If you want to speak to me individually, uh, send me an email. I can set up a Zoom meeting with you one on one. But by the way, how many of you have Gmail accounts? Who doesn't? Okay, who? I put it right. Who does not have Gmail account? Okay, the answer is everybody has a Gmail account. You don't? Let me ask you. If you don't have the Gmail account, how do you log into YouTube and watch? Not Hotmail, Gmail. Okay, you need to get one because the YouTube right now requires you to. Well, let me put it this way. If you want to use all the Google features, you need to have a Gmail account. Otherwise, some of the features won't show up. Yes, it is free to sign up. Get one, please. Yes. No, he lives in 1997. Yeah, please get one. Okay. Okay. Um, yeah, that's everything I want to cover today. If you have more questions, you can log off, and I'm going to terminate the YouTube live in a few minutes. Okay. Yeah. Yeah. Remember, D7 is due this week, and project is due next week, and then that's it. Now on a final. No almost have it.